Hi everyone, welcome back to another video of Engineers Academy. So guys, over here in this particular video, we are going to learn about the discharge measuring instrument, discharge measuring device, that is nothing but the Venturimeter. In this particular video, we are going to learn about its construction, its working, some of its application, its advantage as well as the disadvantage. So guys, there are n number of the flow measuring devices, flow measuring instruments such as the Venturimeter, pitot tube, such as the orifice meter and the flow meter. So basically guys, in this particular video, the Venturimeter, I'm going to explain the details about Venturimeter. So guys, if you are new to here on my education channel Engineers Academy, kindly do subscribe on my education channel and please press the bell icon. So whenever I upload a new educational video, you will get instant notification. So guys, without wasting any time, let's begin with the today's topic of Venturimeter. So as I told you earlier, this particular Venturimeter is a discharge measuring device. It measures the volumetric flow rate. So discharge is expressed in the letter Q and it has the unit of the meter cube per second. So basically, what is volumetric discharge? The amount of the fluid or as the volume flowing through a media, flowing through a pipe. Basically the amount of the flow or as the volume of the flow flowing per unit time. So this is the reason the unit will be meter cube per second. So this particular Venturimeter is having a 3 sections, 3 parts. So basically over here I'm talking about the construction of the Venturimeter. It is having the 3 different sections such as the conversion cone, throat and a diversion cone. So basically over here the length of the conversion cone is shorter than the diversion cone, and this is the reason the cone angle over here it will be around 20 degrees and the diversion cone angle will be around 5 to 10 degrees. So as we can see over here, this is the geometric representation of this Venturimeter. It is having a conversion cone, throat and a diversion cone. So the flowing liquid flows through that particular conversion cone. It goes into the throat. So over here the pressure gets reduced, when the flow goes into the throat, the pressure will be dropped over here in these 2 sections. So if we say this particular conversion cone a section 1 and the throat is a section 2, there will be a minimum pressure drop will occur between these 2 sections. So as we can say that this particular Venturimeter works on the principle of the Bernoulli's theorem. So as over here the pressure energy gets converted into the kinetic energy. So this is the reason the velocity of the flowing fluid through the conversion cone will increase. Over here at the throat we will be getting higher velocity of the flowing fluid. So over here the pressure energy gets converted into the kinetic energy, and we apply, suppose if we apply the pressure taps on these two sections, section 1 and section 2. If we connect a U-tube manometer between these 2 sections, the pressure exerted at section 1 will be more than that of the section 2. So this is the reason we are getting over here the height h. So this particular the pressure difference helps us to calculate the discharge to measure the volumetric flow rate. So basically over here the formula which is used to calculate the discharge, that is Q theoretical. Over here I'm talking about the theoretical discharge, that is nothing but the A1 into A2 into under root of 2gh divided by under root of A1 square minus A2 square. So over here the A1 and the A2 are respective areas at section 1 and section 2. The 2gh, over here the g is the acceleration of the gravity and h is the difference in the height that we can get it from the difference in the height of this manometer level. So this is nothing but the theoretical discharge that we have calculated. So this particular calculated discharge will be more than the actual discharge. The actual discharge will always be less than this particular theoretical discharge. So this is the reason over here we are taking into account the coefficient of the discharge. The values of the coefficient of the discharge varies between 0.98 to 0.9n. It will be always less than unity. So the actual discharge can be calculated, that is equals to Q actual, that is equals to CD into A1 into A2 into under root of 2gh divided by under root of A1 square minus A2 square. So this is the formula that can be used to calculate the actual discharge in the flowing fluid. So over here the Venturimeter, when the particular flow fluid flow flows through the Venturimeter, like there will be a pressure drop. But this particular pressure drop is very much less as compared to the other discharge measuring devices such as the orifice. In case of the orifice, like the flow is directly gets restricted, so that's why in case of orifice we are getting more of the pressure drop. Over here in Venturimeter there is a conversion cone and a diversion cone. There will be the smooth entry of the flowing fluid and the smooth exit of the flowing fluid. So this is the reason we are getting the less pressure drop over here in the case of Venturimeter. Also over here in case of the Venturimeter, there will be no formation of the vortices in the flowing fluid, no formation of the eddies and currents over here occur in this flowing fluid in case of the Venturimeter. So guys, if we talk about the application, this particular Venturimeter is suitable for all the types of the liquids such as the abrasives, slurries, liquid, gases, and some of the the liquids which is having the suspended solid particles. So this Venturimeter is suitable for all the flowing fluids which is having these particular liquids have to maintain the more pressure, that is there will be a less pressure drop. Like we can say that where the permanent pressure loss is not acceptable, not tolerable. So in that cases the Venturimeter is highly suitable. Also it is used in a large diameter pipe which is suitable for the wastewater treatment plant, which is suitable for the waste management basically. It also allows the flow of some of the solid particles through it, like as we have seen earlier, it is having the smooth entry and smooth exit, so that the suspended solid particles, the flow can be easily measured over here in this case of Venturimeter. So we can say that the dirty fluid can be easily measured with the help of the Venturimeter as well. So let's say some of the advantages of this particular Venturimeter. Over here in case of the Venturimeter, the pressure drop is less and it is having a higher coefficient of the discharge. So that is another advantage over here we are getting in case of Venturimeter. It is having high coefficient of the discharge. Also this particular Venturimeter can be installed horizontally as well as vertically, so that the flexibility of the installation we are getting over here in case of Venturimeter. Also Venturimeter is having high accuracy. We can say that it is having the accuracies between the plus minus 0.25 up to 3%. So it is having the maximum accuracy than any other type of the flow measuring instrument. So now let's move towards some of the disadvantages of the Venturimeter. So as this particular Venturimeter is having the higher size, so that the cost of this particular Venturimeter is on a higher side. The maintenance and the inspection over here in case of the Venturimeter is slightly difficult and it is having higher maintenance cost. Also the pipes having the sizes of the 70 mm, the pipes having the sizes less than 70 mm cannot be installed with this particular Venturimeter. So Venturimeter is suitable for the pipe sizes having more than that of the 70 mm. Also this particular Venturimeter is it is always recommended to install this particular Venturimeter in the pipe which is having a longer length for a satisfactory operation. So that's a basically recommended practice over here in case of a Venturimeter and its installation. Also guys, this particular Venturimeter when installed between the pipes, it is having the flange connections and the material is suitable, it is made up of the stainless steel, cast iron and bronze. These are the commonly used materials in the Venturimeter. So guys, that was all about the Venturimeter. We have seen its construction, working, applications, advantages and the disadvantages. I hope you understood this particular today's topic of Venturimeter. If you're having any doubts, any queries, please comment and please do subscribe to my education channel over here, Engineers Academy. Thank you so much guys for watching this educational video.